Swayam Prabha. Digital India. Educated India.
So, last class I have discussed about the Mehrab bearing capacity theory if the foundation is resting on the slope or with a certain depth within the slope. Okay. So, and then I started one example problem where the foundation base was tilted. Okay. So, I will finish that problem first. So, this was the problem that there is a foundation with a tilted base with a angle eta is equal to 10 degree and it is not on the sloping ground. So, beta is equal to 0 degree. So, one vertical force which acting at the center of the foundation that value V is equal to 1000 kilonewton, and one horizontal force which is parallel to the width is acting 300 kilonewton, but HL is not equal to 0. And the phi value is given 20 degree, cohesion is 100 kilonewton per meter square, length of the foundation is 3 meter and general shear failure is considered and depth of foundation is 0.3 meter. So, as I mentioned, as the HL is equal to 0 and the foundation horizontal force is parallel to width. So, we have to take one set of factors and the bearing capacity equation for Henson bearing capacity theory. And so, first I will solve it with Henson, then I will solve it with the basic. So, the Henson bearing capacity theory. So, if I go for Henson, so your for phi equal to 20 degree, NC value is equal to from the table is 14.8, NQ value is 6.4 and N gamma value is 2.9. Okay, so your dF by B which is 0.3 by 2 which is 0.1, so which is less than equal to 1. Okay. So, this information will be required for depth factor calculation. Now, first we will calculate the DC, and I am going for DC because here now we do not need to go for the DCB or DCL, because here only one set of factors we have to determine, because your HL is equal to 0. So, that is why I am writing DC. In previous problem I have given DCB, DCL, because we have to calculate two sets of factors and the bearing capacity equation, that is why. But here only DC, because only one set, actually this is DCB. Okay. So, this value is as it is dF by B is less than equal to 1. So, this will be 1 plus 0.4 dF by B. So, this will be 1 plus 0.4, your dF is 0.3 and B is 2. So, this is 1.06. Okay. Similarly, dQ is equal to 1 plus 2 tan phi 1 minus sin phi square dF by B. So, this is 1 plus 2 tan 20 degree 1 minus sin 20 degree whole square, dF is 0.3, B is 2. So, that value is equal to 1.05 and d gamma is equal to 1. Okay. So, these are the values. Now, we have to calculate the inclination factor, because as we have to modify the shape factor by using the inclination factors. So, first we will calculate the inclination factor. So, that is your IQB, or here I am using B, either you can use B or not, because you can use IQ also, because it is actually IQB. So, here also you can use the DCB or DQB or D gamma B, because these are B. Okay. So, this is 1 minus 0.5 HB and V plus A or A dash, both are same, because it is not a eccentric loading. So, to the power 5, as I mentioned, if nothing is mentioned in the problem, I will use the 5. So, now I have to take that values which is recommended, that for delta I am taking 0.85 and CA it is 0.621. So, I am taking 0.7 C. Okay, these things will be mentioned in the question in your case, but here I am assuming during your design you can assume it within the given range, but in the assignment problem or the exam problem it will be given this specifically. Okay. So, this is point C. So, finally, I will get 1 minus 0.5 HB is equal to 300, then V is equal to 1000, then area is 2 into 3, cohesion is 100, a 0.7 into 100, because C value is 100. So, 100 and then cot phi, cot 20 degree to the power 5. Okay. So, this is coming out to be 0.7. Okay. Similarly, that I gamma B will calculate. So, the I gamma B 1 minus 0.7, and then as I mentioned in the table, if you look at that table of Hensen bearing capacity, so I have given that value of I gamma in two conditions. One, if the foundation base is not tilted, another one if the foundation base is tilted. So, now in this case, your previous question I used the case where the foundation base is not tilted. So, I use the equation as per that, but here the foundation base is tilted. So, I have to use that equation where we can use for foundation base is tilted, and that is this is a third bracket, it is within bracket 0.7, this is eta is degree divided by 450. Okay, eta in is degree value divided by 450, okay, into HB, and then divided by V plus A or A dash CA cot phi, and that we will have to the power 5. So, now if I now put this value, you will get this equation, it is given in the table. So, 1 minus this is 0.7 minus eta is 10 degree, or sorry, I should write 10, okay, 10, and this is 450. Okay, eta is 10 and this is 450. Then the HB is 300, then divided by V is 1000 plus 2 into 3 into 0.7 into 100 into cot 20 degree to the power 5. Okay. So, into cot 20 to the power 5. So, this value is coming out 0.61. Okay, 0.61. Now, I will calculate the gamma C or ICB, which is related to IQB. That is why I have calculated IQB first. 1 minus IQB divided by NQ minus 1. So, IQB is 0.7 minus 1 minus 0.7 and NQ is 6.4, NQ value is 6.4 I think. Yeah, NQ is 6.4. So, NQ is 6.4 minus 1. So, this value is 0.644. Okay. Now, we have to modify our shape factor by using these inclination factors. Though you have to use the one set, but we have to modify the shape factors. So, as per Henson. So, SCB is equal to 1 plus NQ divided by NC. Now, this is B ICB divided by L. Okay. So, now this is 1 plus 6.4 divided by 14.8, B is 2, ICB is 0.644, L is 3. So, this is 1.186. Similarly, IQB is equal to 1 plus sin phi, then B I Q B, then divided by L. So, this B is in suffix, remember that. So, 1 plus sin 20 degree, then B is 2, IQB is 0.7 divided by 3. So, this is 1.16. Similarly, S gamma B, which is 1 minus 0.4, then B I gamma B divided by L I gamma L. That should be greater than equal to 0.6. Now, I gamma L means where the I gamma L, how I can calculate? So, you can see the I gamma L means if let me calculate that I gamma L, which is required for this part. So, I gamma L obviously will be 1, because if you are calculating I gamma L, so in this part in place of HB you have to write HL, and HL is equal to 0. So, that whole term will be 0. So, it will be only 1 to the power 5. So, 1 to the power 5 means it is 1. Okay. So, I gamma L will be 1. So, now you put these values. So, this is 1 minus 0.4, B is 2, then I gamma cube is 0.61, then divided by L is equal to 3, I gamma L is equal to 1. So, that value is 0.837. So, this way I have calculated all the coefficient, depth coefficient, inclination coefficient factors and the shape factors. Now, our foundation which is tilted. So, we have to incorporate that factor. So, here Henson, because this is for the ground factor blast slope. So, GC, GQ, G gamma all will be 1, because it is not a sloping ground, but we have to calculate the BC, BQ and B gamma by using these expressions. So, remember that similar the basics also given. So, you will use these expression and we will solve the basic bearing capacity equation. So, remember that. So, now I will calculate the BC, where BC is 1 minus eta by 147, and remember that here eta is equal to degree. So, 1 minus 10 by 147. So, this is 0.932. Okay. And BQ is equal to EXP 2 eta tan phi, but here eta is in radian. So, what I will do, that EXP 2 eta is equal to 10, then you have to multiply by pi by 180 to convert it to radian, okay? And then it is tan 20 degree. Okay. So, just careful which one is degree, which one is radian is mentioned in the table specifically. So, use according to that. So, this is equal to 0.8 0.881. Now it is now B gamma. B gamma is exp minus 2.7 eta into tan phi. Again eta is in radian here, minus 2.7 into 10 into pi by 180 degree into tan 20 degree. So, this is equal to 0.842. Okay. And as I mentioned that GC is equal to GQ is equal to G gamma, both are equal 1, all are 1, because it is not in a sloping ground. So, finally, if I put these values in the equation, so net ultimate bearing capacity, so that equation is all the factors we have to consider, except the compressibility factor we are not considering, because those data are not available. So, that C value is 100, NC is 14.8, now SC is 1.186, SC is 1.186, DC is your 1.06, then IC is 0.644, then your ground factor GC is 1, and the base factor or this tilted base factor BC is 0.932. So, it is 0.932. Similarly, for this part it will be 6.1, that is the factor, into gamma df, gamma is 19, gamma value is given. No, this gamma value is not given. So, gamma you can consider as the 19 kilonewton per meter cube. Okay. So, gamma is 19, and then your depth of foundation is 0.3, then all the factors. Okay. So, I am just putting all the factors value, as you know which factor is what. So, that means it is 1.16 into 1.05 into 0.7 into 1 into 0.881. Then the third factor, which is half into 19, with is B is equal to 2 meter. So, width is equal to 2 meter, then bearing capacity factor in gamma is 2.9, then all the factors 0.837, then 1, then 0.61, then 1 into 0.842, and then the gamma df, gamma is 19.3, because we are calculating net. So, finally, this value 1162 kilonewton per meter square. So, this is as per Henson. So, now I will calculate as per basic, that how I can calculate the bearing capacity factor. So, initially you want the as per Henson, this is your case 1 and the case 2 as per basic. So, from basic table corresponding to phi equal to 20 degree, we will get NC value is equal to 14.8, then NQ value is equal to 6.4, and N gamma value is equal to 5.4. Okay. So, now I will calculate the SC, and remember that in the previous problem we have taken only one sets of equation and the factors for Henson, because here your HL is equal to 0, but in basic whether it is HL is equal to 0 or not does not matter. You have to take always one sets of factors and equation, and no modifications are required. You can use directly those values which are given in the table, and you can put, because those parallel to L or B effects are already incorporated in the factors. So, AC is equal to 1 plus NQ by NC B by L, and that is 1 plus 6.4 divided by 14.8, 2 by 3. So, this will be 1.288. Okay, now SQ is equal to 1 plus tan phi, that is B by L. So, this is 1 plus 2 by 3, then tan 20, and that is 1.243. Similarly, S gamma is equal to 1 minus 0.4 B by L, that should be greater than equal to 0.6. So, it is 1 minus 0.4 into 2 divided by 3, which is 0.73 greater than 0.6. Okay, fine. So, previous one let me check, which is 0.837 greater than 0.6, it is fine. So, this is 0.3, so 0.3 you have to use. Similarly, DC I will get 1 plus 0.4 df by B. So, this is 1 plus 0.4, df is 0.3, B is 2. Actually, this is your value will come. So, this is the same value that we will get from this here 0.4, 1.06, 1.06. So, this is 0.4, 0.3 by 2, 1.06. So, this value will come your 1.06. Okay. So, 1.06 and dq is equal to 1 plus 2 tan phi 1 minus sin phi square, then df by b. So, this is 1 plus 2 tan 20 degree 1 minus sin 20 degree whole square, then this is 0.3 divided by 2, 1.047. which is roughly 1.05, that is the value I have considered in previous case. Okay. So, 1.05 also you can consider. So, that is because it is 1.047, and then d gamma is equal to 1. Okay. Now, I will calculate those IC, and then IC is equal to IQ minus 1 minus IQ divided by NQ minus 1. So, we have to calculate IQ first. So, IQ is equal to, as per basic, that this is 1 minus H B plus A dash into C A cot phi. A dash and A is same, where this is M. Now, your H is parallel to B. So, if you look at that table were given, if H is parallel to B, how you can calculate M, if H is parallel to L, then how you can calculate M, but if both HB and HL are present, then how to calculate M. So, as it is parallel to B, so your M will be equal to MB, and that is equal to 2 plus B by L divided by 1 plus B by L. So, this is 2 plus 2 by 3, and this is 1 plus 2 by 3. So, this is 1.6. Okay. Again, I am saying that if this is the eccentricity, you use the recommendation to calculate this factor, where you have to use the H or L, or where you have to use the H dash or B dash. Those are already been explained. So, now I can put these values, because here HB in basic, according to basic, it is HB, HL are not required to present or mention, because it is only one set and that is H, but M you have to calculate whether it is HB or HL based on that. So, now this is your H is 300 and then V is 1000 plus 2 into 3, the same 0.7 into 100 I am taking, then cot 20 degree. So, that now m is equal to 1.6. So, this will be 1.6. So, this is 0.787. Now, I gamma will get 1 minus h, that v plus a or a dash C A, because here a dash and a are same, cot phi to the power m plus 1. So, that is 1 minus h is 300 divided by 1000 plus area is 2 into 3 into 0.7 into 100 into cot 20 degree to the power m is 1.6 plus 1 2.6. So, this is 0.677. Okay. So, now I will use these ground factors are all 1 again, because but base factor I have to use by using these tables or these expressions. So, base factor I will use now. So, now the base factor which is given, that my GC, GQ and G gamma all are 1. Now, BC is equal to 1 minus 2 beta divided by 5.14 tan phi. Okay. Now, it is will be 1 as beta is equal to 0. So, it will be 1. Now, BQ equal to B gamma, that will be 1 minus eta tan phi to the power square. So, and eta in is radian. So, this is 1 minus 10 into pi divided by 180 into tan 20 degree to the power square. So, this is 0.877. Okay. So, now if I put these values, I will get q n u net ultimate is all of similar way, all the factors and the values, that is 100 into 14.8 into 1.288 into this is your SQ is 1.28, AC is 1.288, DC is 1.06. So, this is 1.06 into 0.748 into 1 into 1. Okay. So, both the factors are 1 here, plus gamma is 90, DF is 0.3 into 6.4 into 1.243 into 1.047 into 0.787 into 1 into 0.877. Then plus half into 19 is the unit weight, 2 is the width, 5.4, because here it is 5.4. For basic it is 5.4. Now, 5.4 is the bearing capacity factor, then your SC is 0.73, because SC is S gamma is 0.73. So, S gamma is 0.73, then the D gamma which is 1, then the inclination factor is not here. So, we will put inclination factor is here and that is 0.677, inclination factor is 0.677, and then the ground factor is 1 and base factor is 0.877 minus 19 into 0.3 as it is net. So, it will be roughly around 1780 kilonewton per meter square, minus 19 into 0.3. So, it will be roughly again this is 178 or 75 something. So, this will be roughly 1775 kilonewton per meter square. So, roughly 1775. So, as per basic, we got the value as per Hensen, we got the value 1162. As per basic, we are getting 1775. So, these are the value that we are getting. Okay, so now we have solved this problem by using two approaches. One is the Hansen and one is the basic, and hope we understand what is the difference between two approaches, if there is an inclined load, and what is the difference in the basic Hansen approach also, if there is HL is 0 and HL not equal to 0. Because my in previous example 1 related to the inclined loading, as per the Hansen theory, I use HL is not equal to 0, but here I have used HL is equal to 0. So, both the cases I have discussed. So, you hope you understand what are the differences, and then differences between the Hansen theory and the basic theory. But remember that in the both the problems of inclined loading, I have used either HL or HB. I have not used both at a time, but it is also possible the both at a time can be present. So, you have to use it both at a time. Then definitely for Hansen theory, you have to consider two sets of equation and the factors as HL is not equal to 0, but in that case remember that HB will not be 0, there will be HB value. So, when you calculate the inclination factor in both the problems, either we put HL equal to 0 or HB equal to 0, but and the inclination factor corresponding in those cases are coming 1, but here if both the horizontal loads are present, then it will not come 1. According to that, it will you have to calculate. Clear? So, these are the problems. So, next class I will discuss one example problem when the foundation is on the sloping ground. I have discussed the theories, and now in the next class I will solve one example problem. Thank you.